Deep inside the Great Pyramid, a single granite plug sits tightly wedged in the ascending passage at an angle too precise to be accidental. Officially, it sealed a tomb. But the groove that holds it, and the portcullis blocks above the king's chamber, simply don't read like security. They read like a sequence. Lowered, locked, then closed from the outside with no way back. In the next few minutes, you will see why the inscriptions carved nearby may not be prayers, but instructions. One question remains: was this ritual or was it a machine? Stay with me until the end. The ascending passage of the Great Pyramid is barely wide enough for a single person to stand upright in, and for most of its length it climbs through solid limestone at an angle just over 26 degrees. Near its base, 3 granite plugs sit wedged into the passage so tightly that early explorers had to tunnel around them rather than through them. They are not stacked. They are not simply loose. Each one fills the channel completely end to end with almost no visible gap, as if the passage had been built around the exact shape of the blocks before the blocks were ever placed inside it. Officially, this is described as tomb security, a one-way obstruction meant to stop robbers from reaching the chambers above. That explanation accounts for the blocking. It does not account for the precision. When Howard Vyse first documented the plugs in 1837, his survey notes described the fit between stone and channel as closer than anything his tools could measure. The granite itself was quarried at Aswan, transported roughly 500 miles north, and shaped to match a passage angle that varies by less than half a degree along its entire length. Giovanni Caviglia, working the same passage a few years earlier, recorded the same observation and moved on without comment. Neither man had a reason to ask why a tomb seal needed tolerances tighter than a vault door. It simply did. Above the plugs, the passage opens into the grand gallery, and at the top of that gallery sits the antechamber, a low chamber containing 3 vertical granite leaves set into grooves cut directly into the surrounding limestone. These are the portcullis blocks. Their official function is to drop and seal the entrance to the king's chamber after the burial. But the grooves that hold them are cut to a depth and a finish that exceeds what a simple drop seal requires. A block that only needs to fall and stop does not need a channel polished smooth along its entire length, sized to a tolerance of fractions of a millimetre. A block that needs to fall at a controlled rate, under tension, does. Flinders Petrie's 1880-82 survey, still the baseline reference for the pyramid's internal dimensions, measured the portcullis grooves to a flatness most masons of the period would have had no practical reason to achieve. Petrie did not speculate about purpose. He recorded the numbers and moved on to the next chamber. But a groove finish to that tolerance does more than guide a falling stone. It controls the speed and angle at which the stone descends, the same way a rail controls a weight rather than simply catching it. The shafts running from the king's chamber to the exterior surface of the pyramid compound the question. 2 narrow channels, barely large enough to pass a hand through, run at a steep angle through hundreds of feet of masonry. Egyptologists have long debated their purpose: ventilation, ritual pathways for the soul, or something load-bearing tied to the chambers below. What is rarely discussed is that both shafts run close enough to the portcullis grooves to have carried something other than air: a rope, a counterweighted line, a release cord threaded from outside the structure to a mechanism sealed within it. In 1993, a small robotic camera sent up the southern shaft of the Queen's Chamber by engineer Rudolf Gantenbrink reached a limestone slab fitted with 2 copper pin-like fixtures, later nicknamed Gantenbrink's door. A second expedition in 2002 drilled through and found another sealed slab directly behind it, with no chamber, no inscription, and no obvious reason for its presence. No one has offered a convincing ritual explanation for metal fixtures embedded in a shaft that, by the standard account, exists purely for the symbolic passage of the soul. Metal fittings inside a stone channel are not symbolism. They are hardware. This is where the hieroglyphic record becomes difficult to ignore. A short inscription near the antechamber entrance, first recorded by John Perring in 1837 and largely set aside as ceremonial text, uses a register of language closer to administrative quarry records than funerary prayer. It does not invoke gods. It does not describe judgment or the afterlife or the soul's passage into the next world. It describes an action, broken into 3 distinct steps, in the same flat procedural tone Egyptian scribes used to log labour and materials rather than worship. The inscription breaks into 3 components, and the first 2 translate cleanly. The opening term, Giza, means sacred or set apart, appropriate for a burial text, unremarkable on its own. The closing term, Ketem, means to seal or to close, also common in both religious and administrative Egyptian, appearing in granary records as often as in tomb texts. Between them sits a third word, ressu. It does not appear in any other inscription anywhere in the entire surviving corpus of ancient Egyptian writing. One occurrence, no parallel, no cross-reference. Egyptologists who have examined the term directly have rendered it inconsistently. The unseen hand, that which descends, and in one 1923 survey note connected to Howard Carter's broader Egyptian fieldwork, simply untranslated mechanism context. Carter never returned to the term during his remaining years of fieldwork. He had other priorities that year. The word structure is the strangest part of all. Egyptian compound terms for unfamiliar concepts almost always borrow a root from an existing word family. Sound, motion, light, weight, direction. Ressu borrows from none of them. Linguists who have since tried to place it within the broader root system of the language have found no clean candidate, which is unusual for a single inscribed term inside an otherwise thoroughly documented script. The word sits exactly where the inscription describes the sealing action taking place, specifying not that something closed, but how, and the how is the part nobody has ever been able to read. What the grooves, the shafts, and the plugs share is a level of mechanical specificity that ritual alone does not require. A tomb can be sealed with rubble. It can be sealed with a single dropped stone and no channel at all. Instead, this structure has 3 fitted plugs, 3 grooved leaves, 2 angled shafts, copper fixtures buried inside one of them, and 1 inscription describing a 3-step closing action using a word that exists nowhere else in the language. Each piece, alone, could be explained away. Together, they describe something closer to a sequence than a symbol. A process with an order, components, a clear beginning, and 1 step that still has no name. The Grand Gallery itself sits above all of this, and it is unlike any space found anywhere else in the pyramid. Its corbelled walls rise nearly 29 feet, narrowing in 7-stepped courses toward a ceiling barely wide enough to walk beneath. Along the base of each side wall runs a raised ramp, and cut into that ramp, at regular intervals, are 27 pairs of rectangular slots, 54 in total, facing each other across the passage like sockets waiting for something that no longer exists. The standard explanation, set out by Egyptologist E.S. Edwards in his widely cited 1947 survey of the pyramid's interior architecture, treats the slots as sockets for a temporary wooden scaffold, beams used to support workers or materials during construction, later removed once the chambers above were sealed. That explanation fits the slots themselves. It does not fit their spacing. The intervals between pairs increase in a graduated sequence rather than a uniform one, the kind of spacing an engineer would choose to stage a controlled release across multiple points rather than simply prop up a temporary platform. A platform built for human convenience needs even support throughout. A staged release needs uneven support, timed to let weight transfer from one point to the next as a load descends. The slots in the Grand Gallery match the second pattern more closely than the first. Several pairs also show a smoothed, slightly polished wear pattern along their lower edges, the kind of wear produced by something passing through under tension, repeatedly, rather than a beam set once and left in place until removal. At the southern end of the gallery, just before the floor steps up into the antechamber, sits a raised block of stone known as the Great Step, roughly 3 feet high, running the full width of the passage. No comparable feature exists anywhere else in the structure. Its official role is simply architectural, a threshold marking the transition between gallery and antechamber. But a block of that height, positioned at that exact junction between 2 very different chambers, also functions as an anchor point. A fixed edge, a rope could be wound around, braced against, or run over before continuing down into the slotted ramps below. A threshold does not need to bear lateral load. An anchor does. A 1996 structural assessment carried out during routine conservation work measured the wear depth inside several of the gallery's slots and compared it against the wear expected from a single scaffold installation and removal. The depth exceeded that baseline by a wide margin, more consistent with repeated loading over a sustained period than a one-time construction use. The report did not propose what that repeated loading was actually for, or over what span of time it occurred. It simply noted that the wear pattern did not match the accepted explanation, filed the measurement, and recommended no further investigation be scheduled. This connects directly to the antechamber, the low chamber at the top of the Grand Gallery, that holds the 3 granite portcullis leaves. The traditional account, advanced by Ludwig Borchardt in the early 20th century and repeated in most textbooks since, describes the leaves as a simple drop seal, raised during construction, lowered once after the burial, and left in place permanently. It is a clean explanation. It is also incomplete, because it does not address why the grooves holding those leaves were finished to the tolerance Petrie measured, or why slots in the gallery below align with the leaves' resting height almost exactly. Petrie also recorded a detail his own survey could not fully explain. Each granite leaf has a shallow semicircular notch cut into its lower edge, just large enough to pass a cord or narrow line through cleanly. He catalogued the notches without proposing a function, noting only that they served no purpose in a leaf meant to drop once and remain still. A cord passed through a notch, like that does not hold a falling block in place. It guides one, feeding it down at a controlled rate rather than releasing it to fall freely. A newer line of analysis, circulating among structural engineers rather than Egyptologists, questions whether the antechamber functioned only as a portcullis. The leaves sit at a height that would let a rope or cable pass over them and down into the gallery's slotted ramps, turning the granite blocks themselves into anchor points for a counterweighted system rather than passive seals. Under this reading, the antechamber is not the end of the closing sequence. It is the control point in the middle of it, the place where tension from above met release from below, and where a single error in timing could have left the entire mechanism jammed mid-operation rather than sealed. Followed from the king's chamber downward, the pattern stops looking like 3 unrelated seals and starts looking like one threaded system. A rope or cable could run from the slotted ramps in the Grand Gallery, pass across the resting points of the antechamber's granite leaves, and continue down through the ascending passage to the plug sealed deep in the passage below. Each point shares the same signature, a groove or slot cut to a precision the basic function does not require, positioned exactly where a controlled gradual release would need an anchor or a brake. No single chamber proves this on its own fully. The Grand Gallery slots, considered alone, could be construction scaffolding. The antechamber leaves, considered alone, could be a simple drop seal. The ascending passage plugs, considered alone, could be tomb security. But the 3 sit on the same line, at the same graduated intervals, cut to the same unnecessary precision, and connected by shafts already shown to carry hardware rather than air. 3 isolated explanations would require 3 separate engineering decisions, made independently by different work crews at different points in construction, that all happen to align into a single working sequence purely by coincidence. That is the harder claim to accept, not that the builders left behind a mechanism, but that they left behind 3 unrelated systems that, by chance, fit together into one continuous working sequence. The slots stage a release, the great step anchors it, the notched leaves guide it, the plugs receive it. Whatever closed this pyramid did not close it in one motion, at one chamber, with one block. It closed it in stages, room by room, along a single line running from the top of the Grand Gallery to the base of the ascending passage, and every stage along that line still carries the same fingerprint of intention. Every staged release needs a deliberate exit for whoever triggers it, and the Great Pyramid has exactly one candidate built specifically for that purpose, a narrow, roughly 60-foot vertical shaft known today as the well shaft, dropping from a small grotto near the base of the Grand Gallery down to the descending passage far below. Mainstream Egyptology already accepts this narrow shaft as the most likely route construction workers used to leave the pyramid after sealing the upper chambers, a detail rarely emphasized, because it means even the conventional account agrees the closing of this structure was a one-way operation from the moment it began. The shaft itself looks nothing like the chambers it connects to. Where the Grand Gallery is corbelled and precise, the well shaft is rough, irregular, cut at an angle that wanders rather than holds a fixed line. It was not built to be seen, finished, or used more than once. A passage meant for repeated access gets refined over time, the way the Grand Gallery and the ascending passage clearly were. A passage meant to be used exactly once, by people who already knew exactly where it led, does not need refinement. It only needs to work. The upper opening of the shaft sits inside a small, irregular hollow carved into the rock near the Grand Gallery's lower end, a grotto barely large enough for a person to crouch inside before dropping into the shaft proper. Unlike every other transition point in the structure, it carries no groove, no notch, no socket of any kind. It is the one feature in this entire sequence that required no precision at all, because by the time anyone used it, the mechanism's working part of the job was already finished. The grotto does not seal anything, it only lets someone leave. Follow the sequence to its end and the shaft's roughness stops looking like an oversight. The slots in the Grand Gallery hold the stage tension. The Great Step anchors it. The notched leaves of the antechamber guide it downward. The plugs in the ascending passage receive it, sliding into final position under controlled, diminishing resistance rather than free fall. And somewhere in that sequence, after the last block settled and the last line went slack, whoever set it in motion needed to be already gone, already past the antechamber, already down through the gallery, already dropping through the well shaft toward the descending passage and the only path back to open air. This is the part the standard explanation never has to confront, because it never proposes a mechanism in the first place. A dropped seal needs no exit strategy. You drop it, you walk out the way you came in, and the passage behind you was never blocked to begin with. A staged, rope-fed, counterweighted closure is different. It seals its own exit as a structural requirement, not an afterthought, which means the people who built it solved the harder problem first, not how to close the chambers, but how to be somewhere else by the time they did, and once closed there was simply no reopening it at all. A rope under tension, cut or released at its working end, cannot be threaded back through a notch and rewound from the other side of a sealed leaf. A counterweight that has already fallen cannot unfall. The plugs, once seated, fill the ascending passage so completely that even early explorers had to cut new channels through the surrounding limestone rather than disturb the granite directly. The system did not fail open. It failed closed, permanently by design, which means failure was never really the right word for what it did. What makes this harder to dismiss is what the closure took with it. A mechanism built from rope, wood, and counterweight does not preserve itself the way stone does. The granite stayed, the grooves stayed, the notches stayed, but whatever ran through them, cord, line, beam, whatever fed tension from the Grand Gallery down through the antechamber to the plugs below, did not. It either burned, rotted, was consumed in the final release, or was deliberately removed by the same people who triggered it. The act of sealing the pyramid also erased by necessity every soft, perishable piece of evidence for how the sealing actually worked. Stone preserves an outcome, it does not preserve a method. That asymmetry is the real finding here. We are left with grooves cut to impossible tolerances, slots spaced for staged release, notches sized for cord, a shaft built for one irreversible exit, and a single hieroglyphic term, ressu, sitting exactly where the inscription describes the closing action taking place, in the precise spot a technical manual would place its most important instruction. We are not left with the rope. We are not left with a diagram. We are not left with anyone who watched it happen and wrote down what they saw in plain language. The stone kept the shape of the mechanism. It did not keep the mechanism's instructions. There is no later version of this to compare it against. The pyramids built after Khufu's, Khafre's, Menkaura's, and every royal tomb of the centuries that followed used simpler portcullis systems, single-dropped blocks, none of the layered staging found here. It is not only that later builders failed to repeat it, earlier ones did not approach it either. Djoser's step pyramid at Saqqara, built roughly a generation before Khufu's, seals its burial chamber with a single granite plug lowered once, with none of the staged grooves, anchor points, or notched release leaves found at Giza. Sneferu's bent pyramid, built directly before Khufu's, shows portcullis blocks, but no equivalent rope-fed sequence threading three separate chambers into one system. The closing mechanism inside the Great Pyramid does not look like the next step in a slow, visible improvement. It looks like something that arrives complete, fully integrated, with no rough draft preceding it and no refined successor following it. If this sequence was a method, a technique passed from one royal project to the next and steadily improved, it should have appeared again somewhere in the following dynasties, simplified for cheaper labour perhaps, or expanded for larger tombs, but recognisably the same idea. It did not. Whatever produced this particular sequence of grooves, notches, and a one-way exit shaft appears once, fully formed, in the earliest of Egypt's truly monumental pyramids, and never again afterward, not improved upon, not simplified, not repeated. Just used once, and left standing exactly as it was the moment the last block came to rest. The dismissal of the inscription's language did not happen all at once. It happened the way most inconvenient details get filed away, quietly, by people with no reason to look twice. E.A. Wallace Budge, whose hieroglyphic dictionaries shaped Egyptology for half a century, classified texts using the same operational register found near the antechamber as standard funerary formula, grouping ressu alongside other ceremonial terms he considered untranslatable but unimportant. Budge had catalogued thousands of inscriptions by then. One more strange word in a burial text was not, to him, a question worth pausing over. It went into the dictionary as an unknown variant and stayed there. This was not a conspiracy in any organised sense. It was a discipline built to read religious and administrative texts, applying religious and administrative categories to everything it found, including the rare passages that fit neither category cleanly. A field trained to expect prayer reads ambiguous language as prayer. A field trained to expect tomb security reads a sealed passage as tomb security. Once a structure is filed under ritual, every anomaly inside it becomes a curiosity rather than a clue, and curiosities by their nature do not get prioritized for re-examination. The inscription was never hidden. It was simply never asked the right question. That pattern held for nearly a century, until the structure itself forced a reconsideration. In 2017, an international research collaboration known as Scan Pyramids, involving teams from Nagoya University, the French HIP Institute, and Cairo University, used muon radiography, a technique that tracks cosmic particles passing through solid stone to map hidden density differences, and detected a previously unknown cavity sitting directly above the Grand Gallery. Multiple independent detector plates, placed in different locations around the pyramid, registered the same result, which is part of why the finding was taken seriously enough to publish rather than dismissed as instrument error. The cavity, large enough to contain the Grand Gallery itself end to end, was named simply the Big Void. No entrance has been confirmed, no camera has been sent inside it. Years after its discovery, it remains exactly what its name describes, a void mapped from the outside, unexamined from within. The official position treats the Big Void as an architectural relief space, a gap left to reduce structural load on the chambers below, plausible and possibly true, and consistent with similar relief chambers already known to exist above the King's Chamber, but it sits directly above the slotted ramps already shown to anchor a staged release. At the exact elevation, a counterweight system would need clearance to operate without striking the ceiling. A relief space and a counterweight bay would look identical from outside the stone. Both are simply absence, measured by the particles that pass through them. Only entry from within would tell the difference, and as of the most recent public updates, no such entry has taken place. The question the void could answer remains, structurally speaking, unopened, sitting a few dozen feet above thousands of visitors who walk through the Grand Gallery every year with no idea it is there. Smaller proposals have moved slower still, plans circulated among independent researchers to pass a microcamera through known gaps near the antechamber's granite leaves. A non-invasive look at the notches Petrie first recorded over a century ago have been raised periodically and have not, to public knowledge, resulted in any completed survey. Each proposal requires authorization through Egypt's Ministry of Antiquities, a process that can take years even for non-contact methods involving no drilling, no excavation, and no physical contact with the stone at all. The notches have sat exposed, photographed from a distance, measured by hand with calipers, and otherwise untouched by any instrument capable of confirming what, if anything, ever passed through them. Now let me be clear about what is and is not being claimed here. I am not saying the builders of the Great Pyramid had steel cable, hydraulic winches, or any technology absent from the rest of the ancient world. Rope, wood, and counterweight were available to any Bronze Age society with enough labour and enough time to plan precisely, and nothing described here requires anything beyond what Egypt is already known to have possessed. What the stone shows is geometry: grooves, slots, notches, and a one-way shaft, each cut to a tolerance the basic function never required. What the stone cannot show is who pulled the rope, on what signal, in what order, and why this exact design appears once, fully formed, and is never seen again in the thousands of years of pyramid building that followed it. 4 signatures remain, unresolved, inside a structure that has been studied longer, more thoroughly, and by more disciplines than almost any other building on Earth. Grooved ramps spaced for a staged, not uniform release. A granite leaf system notched for chord rather than simple weight. A rough, unrefined shaft built for exactly one exit, and never improved afterward, used once and left exactly as crude as the day it was cut. And a single hieroglyphic term ressu, occupying the precise grammatical position a technical instruction would occupy in any administrative text from the period, translated by every scholar who has touched it into something different, and translated fully by none of them. 4 pieces of physical evidence, 1 linguistic gap. No agreement on what connects them. The granite plug still sits wedged in the ascending passage today, exactly as Howard Vyse found it in 1837, fitted to a tolerance his own tools could not fully measure. The grooves above it still hold their finish, decade after decade, with visitors passing within inches of them, unaware. The notches in the antechamber's leaves still wait for a chord that has not existed in over 4,000 years. The big void still sits above the Grand Gallery, mapped but unentered, its true function still officially undecided. Whatever truly opened this question has never once been the one to close it. The mechanism, if that's what it was, finished its single use long before anyone alive today was born, sealed its own exit on the way out, and left behind exactly enough evidence in granite to prove that something worked, step by step, exactly as intended. It left behind exactly nothing in rope, in wood, or in plain language that explains how. The chambers are still there. The grooves are still there. The question the builders sealed inside is still there too, waiting in stone for the one word that was never meant to need translating, because whoever wrote it already knew exactly what it meant.